There's a new transmission that caught my eye. This is the Dlux OD-4. OD stands for overdrive because it has built-in overdrive, and 4, I believe, because it's the 4th transmission they make that has overdrive. They also have Nod 4, Nod 3, Nod 2, no overdrive transmissions, but this is the OD-4, and it was originally designed for the La Paraloca mini class vehicle, which is about 18th scale. But I think this is possibly a great transmission for 10th scale. So I'm going to break it down and then I'm going to try it at my vehicle. The first thing that's interesting about this is it has built-in overdrive, and it has 28% overdrive. And 28% is kind of the sweet spot for overdrive. If you do the math on a normal Capra-style portal vehicle, you'll find that it's almost impossible to get a 28% overdrive. You can get in the low 20s or the mid 30s, but there's nothing in between. Do the math, trust me, you can't get 28 any other way. So I love that this has 28%. The second thing I like is how small it is. It's quite a bit narrower. The total package, if you're using a small motor, this case it's the Stumpy motor, this transmission is narrower than a standard portal. Just for comparison purposes here, I have a knockoff portal transmission. I don't usually buy knockoffs, but I don't judge anybody who does. This is a blatant and shameless copy of a Dlux portal transmission, and it's quite a bit cheaper, but when something is an exact copy, I prefer to stick to the originals to honor the original designer and support them. So the only reason I have this is for quick fitment into new vehicles and for demonstration purposes. I would not run this in my vehicle. It probably works fine, but I can't guarantee the quality of the materials, the quality of the axles, bearings, etc. They probably cut corners everywhere they could to keep the cost down, whereas an authentic Dlux version is going to have some level of quality control and ensure that all the material specs are exactly what they wanted. So this I purchased purely for demonstration purposes. I only use authentic Dlux parts in the vehicles I actually drive, but I will say I really like this carbon gear cover. I'm probably going to steal this. Yeah, oh, that's nice. That is cut from a plate of carbon. They even milled out the backside. That is really nice. The Dlux one is 3D printed. This one, wow, that really is cut from carbon plate. Sometimes there's 3D printing with a faux carbon pattern on it, but this is really nice. This might be worth the 35 bucks I paid for this whole transmission, just for this part right here. All right, but that's just me. That is a really cool part. So back to the topic at hand. This total transmission and motor is quite a bit narrower than the Dlux portal with a full-size motor. That's one thing I like. But most importantly, the center of gravity is going to sit lower. Let me see if I can mount this. All right, I taped these down. Let's see if we can just get a better visual on what's going on here. I'll try to line that up with the camera. Yeah, that looks good. So you can see the center line of the motor is lower than the center line of a standard sized motor, which is to be expected. But also look how low all the gears are. This all sits a little bit lower than a portal does. So, you know, I talk about lowering your CG. This is going to be a step in the right direction. So let's take a look at the forward drive shaft. Hopefully this perspective will come through on the camera. But this output shaft sits lower than this output shaft by, I don't know, 3-4 millimeters. So that means your drive shaft's going to come off lower, which is, again, a step in the right direction. But what's really interesting is, let's look at the back side. I'm going to flip this around. This is just a little plastic cover that keeps you from losing this gear during transportation. Okay, so now let's look at the rear output shaft. Now, depending what clearance your motor has, you may or may not be running this 1mm carbon spacer underneath your portal transmission. But take a look at this, and I've put these backwards just to kind of compare. The rear output shaft is actually 1 or 2 millimeters higher than a portal transmission. And if you take out the adapter plate, it's maybe 3 to 4 millimeters higher. Now that's great if you are running a mid-bearing carrier where your drive shaft has to go up to a mid-bearing carrier in this way. I like the fact that the front axle is lower and the rear axle is higher. That just plays very well into the layout that I have. Now, one question you might have is, what's the point of putting your overdrive or underdrive reduction in the transmission? It's just as easy to buy a different differential or locker gear, or in the case of a portal, a smaller portal gear. There's 2 other places on the axles where you could achieve your underdrive or overdrive. Well, as I said before, this is 28%, which is impossible to get in the axles. You can only get more or less. Now, if you take a look at this, underneath here is a Dlux portal transmission. It looks like this. And what I've done is I tipped it sideways so that I can run my drive shafts in a straighter line. However, that was actually a big mistake, and I will explain why. Because I run an offset pumpkin, I have to run my axle from this side of the vehicle all the way to this side of the vehicle. And with this transmission, I'm going to be able to run my axle on the same side. So this is a real nice touch. My pumpkin is on the right-hand side. The transmission output is also on the right-hand side. And for the front, if you, like many of us, are running these ultra-short front drive shafts, you almost have to have your output shaft on the side of your motor so that it reaches the pumpkin. So again, this is an offset pumpkin. The drive shaft comes out right on the side I want it to, and on the back it comes out the side that I need it to as well. So another nice touch from this motor. So I'm going to have a super stubby drive shaft on this side, and then the longer one on this side. Now, potential drawbacks to this motor is you do have 1 extra gear that you don't have in a portal transmission. So this total transmission weighs about 10 grams heavier than a typical portal that I was running. But I'm going to make that weight up on the motor because this motor is smaller, so I'm not worried about 10 grams. And it's probably going to be a little bit louder because it's an open transmission. I will do a video on the proper way to lubricate an open transmission. You always want to lubricate your transmission, even though it's not 100% necessary, because loads on RC cars are slow and low RPM and low loads. You can get away without any lubrication, but it's not the best practice. You definitely want some sort of lubrication, and I've been doing a lot of research into dry lubes for exposed transmissions because I knew I was going to be going to an open transmission like this. So this does have 1 extra gear, 2 extra bearings. This is a titanium shaft, hardened steel gear. So it adds a little bit of weight, and it probably adds a little bit of noise as well because we've got 1 more gear mesh that's going to be running in here. And because it's an open transmission, I'm probably going to hear the gears. So I expect this to be a little bit louder. Now let's talk about drive shaft alignment real quick. Let's see. This is my current skid, and I have the motor sitting at an angle like this. And that's so my drivetrain would be nice and straight. But if you've watched my video on universal joints, which I highly recommend, you're going to learn that having a drive shaft that's straight on one end but bent on the other end is going to create a non-uniform output, it's going to make your rear axles, so let's say your motor's at an angle like this, and your drive shaft's perfectly straight, and you have one bend at the axle, this is going to create a rotation at the rear axle. It's not going to be uniform rotation. It's going to speed up, slow down, which you don't want. So I'm going to abandon this design and put my motor back square to the chassis. So I will have the same angle output here as I do here, and these two angles, when they're identical, they will cancel each other out, and you'll get a nice, smooth power delivery. Again, I highly recommend watching the universal joint video to better understand why. But having your transmission sideways like this is a mistake that I made. It's best to have these two angles the same. Even though it doesn't look like it would be as smooth, this is smoother. The other benefit of this transmission, like I said, is because my pumpkin is on this side, the transmission output is on this side. So it's going to be straighter to begin with. And the front, where it's really, really short, is going to be a straight shot to the pumpkin on this side. So I love the output arrangement, even though it means having one extra gear, extra noise, extra weight. So I'm super excited to try this out. If you've seen my other videos, you know I'm working on a new front axle. I have my own custom chassis and skid, and I'm working on a new front axle arrangement. I'll probably put this motor in this arrangement. I have a feeling that I'm going to end up with so many new parts that I'll probably just end up with a whole new second vehicle. I'm going to design a skid for this, and this gives me room side to side. I might have room to pinch this down to 50 millimeters. Right now my width is 55 millimeters, which is quite narrow. And the reason why I like that is I can mount my links on the outside of the chassis. I don't have those sloppy slots in the skid that are always loose. I get my triangulation because the center between is so narrow. So I'm going to design a skid for this. I maybe will make the skid narrower because I've got room for it. And you can see my axle is going to go straight to the bearing carrier here. It's all on the same side, and then it'll come out the back to this side. It'll basically look like this. Really super clean off to one side. Not a big angle like this. That's going to be nice. And then of course, the front one's going to be real short right here. The other variable in this is I'm going to a small stumpy motor. This is a 380 sized motor instead of a full-size 540 size. So you can see how much smaller this motor is. And from all reports, these work great. If you've got a lightweight rig, 5 to 6 pounds, 10th scale, this should be enough power. And I'm going to gear it way, way down to help it out. So the real test will be, do I have enough power and enough runtime from this stumpy motor to justify the other benefits? And for me, the biggest benefit, again, is the lower center of gravity. This whole thing sits so much lower. And then you have the secondary benefits of drive shaft alignment and 28% underdrive to the rear. I think those features are going to make this a real winner for 10th scale. And again, I'm not the only one to try it, but I think it's going to be really interesting, and once I get it all built, I'll let you know how it goes.